All right, so then the question becomes, we've used these two functions, norm dist and norm inverse, really heavily. So when do you use which one? So my response to that would be, think about what they've given you in the problem. Right? Think about what's given to you in the problem. If they give you scores, values, z, x, right? All of those kinds of things. And then you're using norm dist. If they want you to find proportion, percent, probability, area, percentile, rank. I'm trying to think if there's any more I can think of off the top of my head. No, nothing more that I can think of. Right? If they give you this, or so I guess it's more than that. Think about what you're given and what you're asked and what you're being asked to find. Okay? In fact, I'm going to put that up here because it pertains to both of them. Okay? So if you're going to use norm dist, I don't know why I keep saying that. If you're going to use norm dist, then they're going to give you scores. Like, think of the GRE example they were giving us back here. They gave us the score of 800. They gave us the score of 1200. They gave us the score of 1350. They gave us the score of 1100. When they're giving you scores and they're asking for percentile rank, proportions, percentages, probabilities, area, all of that is norm dist or norm dot dist, either one. And technically norm s dist, but we don't have to use that one if you don't want to. Now, when do you use norm inverse? Norm inverse is the one that you use if they give you proportions, percentages, areas, probabilities, percentiles, not percentile rank, percentile. Percentile means, here, when they say what is the 25th percentile, they're giving you a percentage. They're saying 25th, 25%. Up here, they're saying what's the percentile rank, meaning of 1100, meaning the score is 1100, what percentage is below it, right? It's like they're reverses of each other. So when they give you percentiles, right, if they give you those things, then you're using norm inverse. What are they asking for in return? Well, it's a little bit more vague. This one's kind of the hard part to write about all this. But sorry about my pee exploding there on you. But if they want scores, values, z, x, right, any of those things, it's not going to, I'm going to star this just so you know. This is going to be hard to see. It's going to be hard to read in what they write in the problem. So one of the best ways to do it is to keep track of what they've given you. What they want out of you is a little bit harder to read, especially for norm inverse problems. So in general, if it seems like, oh, I'm having a really hard time figuring out what they want, that probably will be a norm inverse problem. Not always, but it will, but often. Okay? And also for the record, I'm not drawing these for my health, right? You need to draw a normal curve for every one of these problems. You need to draw a picture and keep in mind where you're supposed to be. Like, for example, the 25th percentile. There was no way that was over here on the right-hand side. Remember, the 50th percentile is the median. So it helps to draw a picture. If I had come up with a number that was like 1327, I would have known I was wrong. You want to have some vague sense of what it should be. Like, should it be on the left or the right of the mean? That's a good start. And drawing pictures helps you with that. It helps you cut apart. Or when I was doing this problem and I cut the 95 and then I figured out it was 5% in the two tails together, and then it's 2.5% in this tail and 2.5% in this tail. You need to figure those things out, and drawing on a sheet of paper really, really helps a lot. So you don't have to draw it with a computer like I do, but you should be able to draw them by hand. They really help keep track of what you're given and what you're drawing. Just on another note, I always put the X scores down on the bottom axis, and I always put the percentages up at the top. That helps keep you organized.